Hi, everyone. Thanks so much for having us. I'm Sarah Chrisman. I've been with Wayfield for 6 years. Started as their virtual design team manager, and now I'm doing business development for them. Speaking today, we have Duffy. He has been with Wayfield for 4 or 5 years. 4 years, has been in the industry for over 40 years. He's an ISET 4 in fire protection, and he's going to be doing your presentation on switchgear today. And then assisting him, we have Adam Nunn. He has been in electrical for 22 years. I've been with Wayfield for 11 years. And he is now our service account manager, but was a service technician for us for several years prior. So give it up for them.
Thanks, Sarah. Ready?
Yeah. All right, everyone. Share the screen.
So we do fishing, hunting. We have got to join this club.
This is where it's at.
This is where it's at, yeah. So thanks, Sarah, 40 years in the industry. That's like getting your first senior citizen discount, right? She's going to get the presentation up. All right, so I'm going to talk about switchgear maintenance. How many people here in the room have seen a switchgear failure? They are, yeah, it's a pretty exciting event, right? Yeah, it's no fun, right? All right, so let's get started. Go ahead. I think this space bar.
There we go.
Okay. Obviously, when a switchgear malfunctions, it's usually a catastrophic failure, right? Actually, a lot of the failures you'll see, it's a slow burn where you have a termination, because it's a termination where all electrical fails, right? It's the biggest point of failure, and it's overheating and overheating for years and years, and that's probably more common than actual catastrophic failure. Go ahead. So you can see up in the top, I put correlate because I am struggling with this word. Damage can be extremely expensive, but pales in comparison to corollary damage and the potential hazard for people. I would say corollary. I don't know why we just didn't put collateral damage, right? Because that's what we're talking about. And hopefully when we have a failure, we do not have anybody injured. Most of the time, when these things happen, it's when there's a human involved manipulating things, right? They don't just blow up when you just walk by them. Okay, so thus, and we're going to say this a couple of times, implementing effective switchgear testing, inspection, and maintenance program is essential. How many people here actually have a maintenance program for your switchgear? Okay. How about for just your main electrical system? You guys go through it, even if you're just doing it in-house. Okay, so what we call this in the field, boots on the ground, this is a scheduled outage of a known duration. We're going to shut the gear down. We're going to do some dusting and cleaning, right? We're going to check it out. The flip side of this,
The flip side of this
is, and I hate these phone calls. It's like, sir, we have an unscheduled outage for an unknown duration. What's that mean? The gear blew, and then the customer's like, when are we going to get the power on? I don't know. How long does it take to get switchgear parts into town? 12 weeks, right? Is it an old switchgear and they don't even manufacture the parts anymore? So when people ask us, besides the danger factor is, can you work it energized? You know, our first instinct is, well, no, we don't want to work it energized just because of the hazards. And if something happens and the gear gets blown, now you are down, and I don't know how long you're going to be down, right? So schedule the outages. And we tell people a lot that we can come in 4th of July, we can come in New Year's Eve, we can come in after hours. So if you want to, you can get things shut off. Agreed? Okay, next. Okay, here's the 3 most common failures: humidity and internal arcing. We live in Colorado, so humidity is not a big issue. But with the dry climate, what is the big issue? You can build up static charges, right? Dust, surface contamination. You'll start getting like carbon tracing, carbon arcing, and all of a sudden it'll follow that tracing. We'll get a short circuit. Mismanaged heating resulted from either overloaded equipment or deteriorated connection points. And again, it's the terminations. Where the wires terminate, that's your biggest point of failure. Okay, most common maintenance activity, visual. So which visual? Look at it, right? Don't just walk by it. Clean the switchgear regularly. Infrared thermography, phenomenal. It's probably the best thing that's ever happened to the maintenance industry. Function test, open the breakers, close the breakers. What was the last one we did? It was AECOM, and I think it was CBRE. Were any of you on that project? Yeah, in that building, we're doing a big TI build out, and I guess CBRE had just purchased the building. Well, we went downstairs, and they had switchgear, the old Pringle switches that you crank up. It had to be 20, 30 years old. And all of us, including the facilities maintenance, we said, we are not going to open that with a load on it because we had no idea what it would do. And you could look in the window and see that much dust. So we had the utilities shut the gear down. We operated the Pringle switch. The 3 blades stayed stuck, and the arm operating and broke all 3 blades. So what would have happened if we actually, and we're all looking at each other. I'm looking at, my technician, you open it. And we're looking at, the facilities, you open it. He's like, I'm not opening it. So common sense prevails. And torquing if needed. Okay, go ahead. Okay, so types of maintenance. Okay, you got run to fail maintenance, bad idea, right? An example, replacing an indicator light only when they fail. Well, how'd you know it failed if it didn't light, right? So, running your truck until the tires fall off, probably a bad idea, right? Okay, next. Okay, then preventative maintenance, which is what most people are doing. And that's like, we got a schedule, we're doing cleaning, lubricating, or exercising the disconnects, right? That's pretty good. This one's the best, predictive maintenance. So we're gonna do annual visual and thermographic inspections on the switchgear. And we're gonna see things starting to fail, starting to heat up, and we can predict. We got a time frame. Hey, let's get on this, let's maintain it, let's fix it. Okay, so I'll say it again. Implementing effective switchgear testing, inspection, and maintenance programs is essential if you want your gear to last, right? You can't park your truck in the driveway and never drive it, or it'll just rot out. Okay, so there's 2 standards. There's NFPA 70B, which is the recommended practice for electrical equipment maintenance. And then there's NETA, and it's the International Electrical Testing Association. So I don't know why their acronym doesn't say INETA, but it's NETA. And they're the guys that set up all the standards of how to test breakers, test electrical equipment. If you followed all of NETA, I don't think you could afford it. It's like a government agency. Go ahead. And always, 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 and I put that ahead of the standards, manufacturer's recommendations, right? Any gear you buy that you get to manual, they tell you right in the back, this is what you should do, this is what you should do. Okay, so when you get a brand new building, the electrical contractor, you get your brand new switchgear, they're gonna install your switchgear according to the National Electric Code, right? It's gonna get inspected by the city, and they're gonna probably certify the gear according to NETA, and it's usually in most of our specifications. So we'll bring out electro test. Adam, what's some of the other breaker testing companies?
There's quite a few of them. There's Denver breaker, I mean, you can bring them in, or you can take them in to get bench tested if you need to. Sometimes it's an option, but not usually if it's in the gear. If it's in the gear, it's going to be bring out a manufacturer. They'll have somebody like Siemens will have a rep that can come out on site, test breakers, things like that.
Yeah, and they're gonna, thank you, Adam, they're gonna set up the breakers, they're gonna test them, and it's pretty cool to watch them. I've seen them bench test them, and they'll inject them with current, and they'll force them to a trip. And they're gonna do all your settings from the engineer, your trip settings, right? Because out in the field, what do they, when in doubt, crank it all the way up, right? It will never trip. Bad idea, agreed? So you're gonna receive your gear totally set up and in, perfect operating condition. Go ahead. Then you got a year warranty, right? And then basically you're going to inherit the gear after that 12 months. And then NFPA 70B is a good recommendation. And NETA does have maintenance recommendations in their documentation. I'm going to show you that. And then again, the O&M manuals, manufacturer, right? Follow their instructions. Okay, and I can't stress this enough. Under both conditions, when we are commissioning a gear or when you are doing maintenance on a gear, once you get those covers off, you're exposed to what? Energized live parts. Okay, NFPA 70E will kick in and you got to protect yourself, right? You got to wear your arc-rated clothing. You got to have training in this. And, I do a lot of training for NFPA 70E, and I'm an NFPA certified trainer. First slide we put up is we are not certifying anybody to blow yourself up, right? We are certifying you that you took this training, right? What's the best rule of thumb? Turn it off, right? And the definition of off is just mind-numbing of what people call off. I'm like, no, off is like off. No power, right? Off. But can I always turn it off? No. If I'm going to do diagnostic testing and I got to touch it with meters, I got to have it on, right? If I'm going to do any kind of flare or infrared, and yeah, hot shots, you do it, right? You got to have the gear on. You got to have it warmed up and under load, right? So there are certain conditions that it has to be on. Okay, go ahead. Okay, so this is 70B, and I cut this right out of the code book. So the item switchgear assemblies, infrared scanning, they're recommending you do it once a year. The enclosures, the security operational for outdoor 1 to 3 months, indoor 6 months, visual inspection, outdoor 1 to 3, indoor 6 months. And I don't get the visual, but is that on a different 6 months? Because I don't know how you can operate it and not look at it, right? With fire alarm testing, you functionally test it once a year, pull the pull station, smoke the heads, and then at 6 months you look at it. So you're going to look at it twice. So I'm assuming this is the same. At 6 months I look at it annually, I functionally check. Nope, go back one. Okay, ventilation. Obviously, you don't have boxes stacked around your gear, right? Mop. Agreed. Not the mop room. Space heaters. What are the space heaters? In high humidity, a lot of the gear has space heaters that knock the humidity down. They put little heaters right in the gear. Insulation, visual inspection annually. Okay. Space. Okay, so this is NETA, and it's a little different. First, they have a table that you rate the equipment reliability requirement. I don't know anybody that would say, oh, my switchgear I have a very low reliability requirement, right? Seems kind of silly. I would say a hospital has a very high requirement, right? So let's say in your buildings, they're commercial, let's say you're a medium requirement, right? If the gear goes down, probably not going to have people die. Agreed? I mean, inconvenience. Right? A hospital, you know, you got to have generators, backups, redundant. And then let's say your switch gear, let's say it's at a good rating, right? So you're going to rate your gear low, medium, high, poor, average, good. And if you see how the numbers flow, in the poor category, these are multipliers. I'm going to inspect the gear more. In the good category, I'm going to inspect it less. So let's say you're at a medium and good 1.5. So go ahead. So switchgear assemblies, I want a visual inspection once a year. Well, hey, you're at a good. So we go times 1.5 and we can stretch that out to 18 months. Make sense? If you were at a bad, it would have gone from 12 months probably to what? Maybe 6 months, right? If you're at a scary, maybe you ought to get new gear. Okay? Okay, next. And here's the bottom thermographic survey. They were at 12 months, right? Well, you're at 1.5, you're allowed to go to 18. Right? And if you could go back a slide. There's a whole bunch under this. There's transformers, big transformers, little transformers, motor control. If you go to NETA, I downloaded this for free. And then just search for free maintenance, I forgot what they called it, maintenance timing or something. Yeah, you're gonna have to put in your email and your contact info and they want to send you stuff, which is okay, but you can download this document. Okay, and I knew, I looked at 10 and 11, I thought somebody's going to ask me, what the heck is that? Electromagnetic field survey and online partial discharge survey for switchgear. Yeah. You know, I kind of figured, okay, electromagnetic, it's got to be what? It's got to be some kind of high voltage stuff, right? The only time I worry about, you know, electromagnetic fields. So I Googled it. Go ahead. Okay. And that's what it is. You see he's got a magnetic sensor and he just clips it and he's going to pick up that static charge from medium and high voltage gear, right? And you see on the meter it says PD scan. That must be partial discharge, right? So it's an electromagnetic field. And I really like their meters. I mean, that's pretty cool. You get a green smiley face, you pass. If you get a red bad face, you fail. So, I mean, how many people actually have medium voltage gear in your buildings? Generally, we're running at what, 480 is the first one coming in. But we see in construction more and more and more. We're having 5 kV, 13 kV on the site. As we call it, behind the fence. On the other side of the fence is what? The utility. And once it's on our side of the fence, it's the National Electric Code and it falls under our jurisdiction. So if it's on our side of the fence, 13,000 volts, it falls under our purview and we have to maintain it and handle it. You're going to see that in a lot of big data centers. They'll bring 13,000 right onto the site. Okay. Okay, manufacturer's recommendations. Go ahead. So this is from Siemens. I downloaded their manual. Of course, they start off with the user must establish a periodic maintenance program, right? That's essential. They're going to reference 70B, right? And then they have their disclaimer, just because you do preventative maintenance, that is not major repairs or major builds. Agreed? Not part of maintenance. Okay, next. Then they start going through before maintenance. What do we do? Turn it off, turn it off, turn it off. Unless your maintenance is what? Unless you're going to flare the gear, right? You got to have it energized. And they have to say that on it. Turn it off. Okay, next. Okay, include the following items. You can see it's pretty common sense things. Check general condition of switchgear installation. You're looking for dust, dirt, foreign matter, clean the filters, check all your indicating lamps, terminal block contacts for loose connections, and number one biggest failure is going to be loose connections, right? Okay, next. So they have, it goes all the way down to R, right? Perform maintenance of circuit breakers outlaid in the circuit breaker installation manual. So really, switchgear, I mean, there's not a whole lot that can go wrong with switchgear, right? It's a big box with bus bars, right? And you got conductors terminated to it, so it's only where the conductors are terminated. Where's your big failure? It's in the breakers, right? Which is not today's discussion. But breakers generally don't just, as long as you operate them, you got to open them, you got to close them. If you let them sit there 20 years, what's going to happen? The grease on the blades is going to dry up, and those blades are going to get stuck in the holders. And when it goes to trip, it's just going to lock up and it won't open. So you got to open them, you got to close them, right? Okay, go ahead. So this is cool. So when you get in your manual, they show, you know, your flow chart of all your parts, right? So this is the inside of a cubicle. And how many people here have those rack in, rack out breakers? Good. I won't repeat that in a public setting again, but I like the bolt in, right? The rack in, rack out are nice, because you can just turn the handle and the breaker comes out and you can maintain it and check it. Don't rack it out when it's live. And don't rack it in when it's, they say you can. And you see these little yellow, those are little windows. And when you rack it out, the little windows close and they're going to keep you from touching the live parts on the bus bar. So I can pull out one breaker, maintain it, put them in. Back in the day, they used to have little steel windows, and sometimes they wouldn't open up, and you go to put them back in and touch the side and blow up. We hated them, you know. So what I do is just turn it off, you know, take it out, right, and never underload. And when you're exercising breakers, what should you do too? Just start turning on, turn it off. Go downstream and take the load off it, right? You don't want to close an 800 amp breaker onto an 800 amp full load. Agreed? So go downstream, turn off the panel boards downstream, open the big breaker, close the big breaker, and go down and turn on the load a little bit at a time. Agreed? Because you know you just don't want that surge of current coming in. Because when I'm operating, all I'm doing is making the mechanism click in and out. Okay. And you go through their manual. They have every single little gizmo that's in your switchgear, meters, contacts, and they tell you how they work and how to maintain them. Okay, so here's the recipe. Most real-world maintenance programs are a combination of these approaches, right? You might not follow 70B perfect, you might not follow NETA perfect, but you just come up with your own. And when we're looking at this is really not rocket science, is it? Great. So number one, my recommendation, manufacturer's instructions. Get those manuals out, read them. Number two, look at the standards, right? Number three, we want a double scoop of common sense here. Yes? And we're going to do cleaning, visual, FLIR, and torque when it's needed. Okay, next. Okay, so visual. What's visual? Okay. Right. You got to get those covers off, right? That is probably one of the number one or number two most dangerous things when you look for NFPA 70E is taking bolted covers off of live gear. And why is that? You drop them, and it would fall this way, this way, this way, a million times. But if I got a live gear, guess which way it falls? It goes right into the gear. You know, so you get the covers off, right, and you just start doing a visual inspection. Go ahead. Hey, pretty obvious, right? You see things like that, it's overheating, right? I didn't have to FLIR that, right? Okay, next. Okay, cleaning. You get on a cleaning program, order the proper, the manufacturer will recommend them, but they have switchgear cleaning materials. You don't use Windex or, you know, they have, it's almost like alcohol that evaporates, it cleans the grease. It is designed and it's built for cleaning switchgear. And then you shine it all up. Okay, torque, go ahead, you're good. Okay, so torquing, you can over torque and you can under torque. When I say torquing, we usually think of what? We didn't tighten it enough. Because before torque wrenches, what did we do? One grunt, oh, that was tight. Really tight, was two grunts, right? That's how we did it. Over torquing, especially with aluminum wire, right? You crank that aluminum wire down and it's called cold flow. It starts getting heated up. It gets soft. And you know, if you've got aluminum feeders, I would check the torquing once a year or flare it once a year. Because aluminum, you know, it's got the cold flow. Copper will stand up for a long time, right? So just tighten it as hard as you can. Bad idea, right? Okay, go ahead. Okay, so get the proper tools. And you can see here, if you look in your gear, you'll see the electricians, they write right on the gear. Torque to 40 pounds, and you notice the little marks. That's what we train our guys. You torque it, you take a marker, put a stripe on the bolt. That way, you know, when I do it, and then Adam comes in to inspect, and he's like, Duffy, there's one without a mark. Did you torque it? Well, go back and check it. So we make sure, all our guys, you've got a mark every single bolt you torque. Go ahead. Okay, here's some common sense fails. That's my grandkid up there. I told him, tie your shoes. Seriously, you'll never be an electrician. Good thing it's not raining. This one, I love it. Let's take our flip-flops and float power strip, right? So, okay, next. Flare. Which flare? It's from the military, right? Forward-looking infrared. Coolest technology on the planet. Okay, so visually, hey, that looks okay, doesn't it? But it's not. We threw a camera on it. Hey, we got a hot spot, right? So, you know, unless you see the insulation, you know, kind of cracking and looking like some heat stress, right? Or you see that little rainbow, you really can't tell. Okay, so this is an example of, you know, we do this infrared thermography, and you get a report. That's the cover page. So this one was for Hoop Trelleborg, right? Submitted by Adam Nunn. There's Adam Nunn. There's that. What a handsome lad, isn't he? Huh? Just like the picture. So this was like 168 pages. So I just pulled a few out, you know, just so you can see what it looks like. And the cameras come with software, you know, and I think the software is harder to operate than the camera, right? Yeah. So go ahead. So here's an example. We have the real picture. Then we have the infrared picture, so you know what you're looking at. This is, I don't know what, yeah, mechanical report 8J. And you can see potential problem, no, right? And I've cut off the bottom. There's a whole bunch of other data and information here. Is your guys' stuff pretty much like this? Okay, go ahead. Here's another one, right? And see it's 75 degrees, right in the middle, right? No problem. Next one. Oh, there's a problem. Look, and I don't know if you can see it online, but we're at 119.4. You see that hot spot? And the good thing is, you know, if an electrician is doing this, immediately we can clamp on and we'll look at the amperage right away. And we'll see, hey, do we have an over amperage or anything like that? Does that make sense? Okay, and so it says recommend checking B phase for proper torque. Okay, go ahead. Okay, this is the second image after B phase had been torqued. So somebody had torqued it down, recommends shutting down the panel and checking the fuse holder as well as the torque on the bolt that's holding the lug on. So we torqued it down, or we have the building guy torqued it
Building
down?
maintenance guys on that one did their own stuff. They were licensed electricians at that facility.
Right. So they torqued it down, and then we shot it again, and you can see we're cranking at 100.9, and we threw our, you know, our amp meters on it, our clamps, and say, hey, let's see what amperage it's on, right? So still didn't fix it, and then the next one. So they went in, and I know it looks bright, but you got to read the numbers, right? And they took the corrective action of fixing the fuse holder, and it brought it down, so we found it. So, I mean, these FLIR cameras are just cool. Firemen use them a lot. They'll just look at the walls, and we can tell if there's a fire inside the walls. The military uses them. They'll look at a bunch of vehicles. They'll do a flyover, and they'll see which vehicle still has a hot engine. Not allowed to use it for hunting. Right? Okay. So in my opinion, the advent of thermal imaging and FLIR is the best thing since sliced bread when it comes to electrical maintenance. I mean, it's the only way to go. And mechanical contractors use this a lot. I got a buddy, he'll shoot your windows, and we can see where the windows are leaking, and they'll shoot fans. You know, we're strictly going to do electrical motors, switchgear, things like that. But you can use it for just about anything. Okay, go ahead. So my recommendation, it doesn't matter who you hire, okay, but make sure that they are certified by some organization and they've gone to the training. And I'm sure you guys are all certified. But make sure it's not just two guys with a camera, right? And these classes are tough, right? They're tough.
I've actually been to a facility where they actually purchased a camera before, and just their facility maintenance guys tried using the camera, and they took some images and they found one lug on it was on a air handler, and it was loose, showed a hot spot. Guy went in there, shut it down, torqued it at night, snapped the bolt right off. It actually wasn't in that. It was in the mechanism for the on and off switch for the breaker to shut down that piece of equipment. So they did more damage, not being certified, not being like a, you know, technically a licensed electrician kind of thing. So, you know, just getting the camera isn't enough without the training. The training really helps a lot. Also, I don't know have any of you guys used one of these cameras before? Have you? Have you noticed how everything's real hot? Even when you're looking at bussing or a piece of metal, it shows that it's really hot, and it's not. It's just the emissivity. It's the reflectiveness of the metal. The only way to really shoot that, or shoot like even a window, is to put something on it, like a piece of black electrical tape. Then you're going to get an accurate measurement of that temperature on it. And you don't learn that unless you take some sort of a class, get some sort of certification. So you can go out and buy a camera. Anybody can buy one of these. They sell them for your phone now, attachments. But being certified is really big. It's really important.
Yeah, and I highly recommend it. So having a camera is cool, but when it really gets down to it, call the professionals, right, and get them out there. You know, and they're electricians too. So when we're shooting a piece of equipment and we see the lugs, I mean, that's our world. We have a pretty good idea of what's going on and what's happening. Right? Okay. Getting close to the end. Oh, happy St. Patty's Day. My name's Duffy, and I'm working on St. Patty's Day. What's up with that? Right?
Not for long, right?
Not for long. This is it. That's why I volunteered. Okay, an apple a day keeps the doctor away. Agreed? Maintenance. Okay, next. So Dr. Duffy says, FLIR your gear once a year. Right? So I was trying to come up with a jingle like the My Pillow guy, but I couldn't come up. Yeah, my wife's like, that's stupid. You're not going to put that on there. I'm like, I'm going to do it. I'm going to do it. So just remember, FLIR your gear once a year. Okay, questions?
Well, I kind of have a comment.
Yeah.
So on your baseline images that you showed, I mean, I guess I have a question as to whether or not it's really valuable to provide a client with a baseline image if you don't have the amp reading there. You don't know, like for instance, you have like hundreds of baseline images. And if you're not the thermographer in that room who's looking thermal reflection. Well, let's pretend Mike goes in, takes this image. He knows, hey, I got a transformer behind me and I'm catching a reflection, right? And he doesn't write it up because he knows it's not a problem. It was a reflection that he was catching. And so my question is, if you're just providing baseline images without information like that to say this isn't a problem, you know, emissivity issue or something like that, and what value is it if you don't have the amp reading to go with it? You don't know the loading at the time you were there. So I think baseline images are questionable to me as to whether or not they're very effective, because the only person who really knows whether or not there was a problem there is the guy who was standing there in the field live courtroom.
Yeah.
So you were touching on that with the emissivity issue. And emissivity is very complex. It's a difficult thing to adjust for. It's hard to understand and to be able to deal with it in the field, especially when you're talking about looking at a bunch of aluminum, which is very reflective. So anyway, I'm wondering about your thoughts on whether or not you guys think you really need to be providing amp readings on everything if you're just providing a baseline image.
Generally, most of our clients are looking for us to be the ones to make that decision in the field. So if I see something hot, being an electrician, I'm going to know if there's an issue and I'm going to be able to look at it. I carry my amp meter with me. Generally, we have some clients that only want an image and something on the report with something that's a problem. In the beginning, a lot of them want a baseline. Case in point, water treatment facility. A couple years ago, took images, did a whole thermal image report on a facility for them. A year later, we went back, did the same report. I told the super there, I said, hey, we had this come up on the last image, on the last report we did. And their building maintenance guys never fixed it. They never got it repaired. They were going to do it in-house. So,
but you documented it as a problem yourself.
Yes.
So that one was different than just saying, hey, here's a slew of images of all your gear. Because I think the reason people will ask for baseline images sometimes is they want to make sure that it really didn't have a problem. But my point is, if you're not there and you don't have the amp reading there to go with it, they don't really know, is the guy sitting behind the desk looking at these images whether or not there was really a problem. And I think that's the goal of baseline imagery, is to be able to say, hey, we looked at this, here's what it looked like, there was no problem. But if you don't have that amp reading to go with it, I think it's not really valuable. I question the value.
Yeah, I would question the value also, but we're looking to get more work out of the work, right? So we're out there trying to take pictures. We're out there trying to get our foot in the door, get in the building, do more work for you guys as a client. And if I see a problem, I want to point that out.
Of course, yeah, and that's what you would be hired for if you're doing an infrared inspection, is tell me where the problems are. But my point is only that these baseline images are pretty worthless. What matters is, do I have a problem or don't I?
Yeah, and I think what my opinion, what's really key is your thermographer is an electrician. I mean, that's really key because they know exactly what they're looking at. And I agree, yeah, getting
I hate
the
to differ here,
Yeah.
but that's okay.
Yeah. Well,
I'm just
yeah,
saying,
we're not here to compete.
we're not,
Yeah.
no.
Because, they're going to take the amp readings, and I agree, the amp readings, I see anything out of whack, it's like, let's get some amp readings and see where it's running at. Because all circuits should be running at what? About 80% of the breaker. Agreed? Yeah, I can run it up close to 100% of what the breaker is, but, once I do that, it's going to start heating up and getting warm, and over 30 years, things are going to wear out. But, eventually, you get a hot spot, you are going to have an electrician looking at it, So either way, the more data, the better, right? Agreed? The more data you can give to you, this is what I'm seeing, this is everything I got, right? Yeah, and if you could get baseline images, like you walk into a 30-year-old building, it is what it is on that day. And then, we're gonna have to ask you, hey, can you ramp up this circuit? I need this circuit operating at what? Yeah. or at whatever he operates at, you know, we're not gonna walk in cold. Get this motor going, run it for a while, let's everything, bring it up, let it stabilize, and now let's get some shots of this is where it's running all day long. Cool, cool. Any other questions?
I guess one other thing is I'd just like to say one more thing. It's not about infrared, it's actually about switchgear testing. I completely agree with you guys that you need to be doing the torque and tightness, you need to be exercising the equipment, and you need to be doing your switchgear maintenance. And the reason is, I cannot tell you how many failures we have seen over the years where the equipment didn't trim. It is so normal for the equipment not to trim. We're always pleased when we see, wow, your equipment trimmed. That's awesome. So it's a big deal. And if you guys aren't doing it, I would say make it important in your electrical maintenance program. It's important.
Yeah, and you remember the old Zinsco breakers? Zinsco, and what were the other ones?
Federal Pacific.
FPE,
Yeah.
anti-trip breakers. They just never,
Yeah, they're terrible.
yeah. Okay, cool, cool, we good? Yay. Thanks.
Thank you, guys.